Hello, welcome everyone. We're going to get started today. Our first presenter is going to talk about the effects of video examples in teaching hypothesis test selection. Abra?
Thank you, Angie. Thank you for coming, everyone. I'm Abra Brisbin. I'm an associate professor of math at UW-Eau, and this presentation describes joint work with my student, Andrew Senapati-Ratney. I've also put a couple of links in the discussion forum that you can check out at any time during this talk. One of them is an app that my student created so you can explore the data yourself. And the other is a YouTube playlist containing the video examples that I'll be talking about. And I would welcome any of you to use those video examples in your classes if that's appropriate. All right. So many studies have found that reading worked examples improves students' learning. And it seems to do this by slowing the process of forgetting. This effect is most beneficial for novice learners. And that term is deliberately kind of vague. It seems that reading worked examples is most beneficial for students in their first few contacts with a new topic. And one possible reason why reading worked examples improves learning is that it may reduce cognitive load compared to solving practice problems. So students need to keep less information in their working memory in order to successfully understand a worked example compared to solving a practice problem. But as you probably have noticed, getting students to read is challenging. And that's true even when they acknowledge the benefits of reading to their learning. So I wondered, what about video examples? Watching videos might hold students' attention better because they're already accustomed to watching videos on their phones for entertainment. As an additional advantage, it could reduce cognitive load for dyslexic students. So in order to investigate this, I used two sections of introductory statistics in fall 2019. One section of regular introductory statistics and one honors section. I started each class by giving a 15-minute lecture on the process of choosing what type of hypothesis test to use. And at this point in the semester, students had learned about 1 and 2 sample t-tests and 1 and 2 sample z-tests of proportions. I also talked about how to identify scenarios where none of these 4 types of hypothesis test would be appropriate, such as scenarios where you would want to use an ANOVA. Then we randomly divided each section into 2 groups, with Group A solving practice problems and Group B watching video examples of the same problems. Then the following day, the groups switched their roles with a new set of problems. So here's an example of the problems that students saw. So we didn't ask students to actually conduct the hypothesis test, just to identify which type of test they should check the validity conditions for or consider using. So in this example, you would want to consider using a 1 proportion z-test, and then decide whether the validity conditions are met for this test. So in this example, only 8 customers got their coffee at this coffee shop, so the sample size is too small, so we would not actually want to use a 1 proportion z-test. We gathered data on students' perceptions of the difficulty of each problem as a proxy for cognitive load. This was on a scale from 1 to 5, with 5 being the hardest. We gathered data on their short-term performance using a pre-test, a mid-test at the end of class on day 1, and a post-test at the end of class on day 2. And their long-term performance using their score and the number of attempts they made on homework problems involving hypothesis test selection throughout the rest of the semester. And homework for this class was administered through WebWork, which was set up to allow students to have unlimited attempts on each problem with no penalty. We analyzed the data using a Bayesian approach using the R-stan-R package. Now, if you're not familiar with Bayesian analysis, the essential idea is that we're treating the effect of doing practice problems on day one, as well as all the other factors we analyzed, as a random quantity. And we're simulating values of that effect that are consistent with the data. So then we're interested in whether 0 is a likely value for that effect. If it is, then it's plausible that there is no effect or simply a very small effect that could be either positive or negative. If 0 is not a likely value, then we conclude that there is an effect, either positive or negative, depending on the values we simulated. So we found that there was a moderate association between doing practice problems first, that is on day one, and rating problems as hard, either a 4 or a 5. So what you're looking at here are the 80% and 95% credible intervals from our Bayesian analysis. So for example, the effect of day 2, that credible interval is centered pretty close to 0. So based on this, it's believable that whether students are in day 1 versus day 2 of the study, they're approximately equally likely to rate a problem as difficult. But the credible interval for the effect of doing practice problems on day 1 is shifted to the right. So this is showing us that students who do practice problems on day 1 are slightly more likely to rate problems as being difficult. However, we found that students who did practice problems first had better short-term performance on the mid-test and post-test. So in pink, here are the credible intervals for identifying whether the validity conditions of a test are satisfied. And the credible interval for students who did practice problems on day 1 is completely above 0. So there's a greater than 95% chance that the effect of practice problems is positive. For identifying which type of hypothesis test to try, we had a largely positive credible interval for the interaction between day 2 and practice problems. So this is showing that students who did practice problems on day 1 are more likely to correctly identify the hypothesis test on day 2 compared to their classmates who did video examples first and practice problems second. However, students who did video examples first had better long-term scores on the homework. So here you're seeing the credible intervals for the effects of various factors on how likely students are to get a homework problem correct in their first 1 or 2 attempts at that problem. So for example, you'll notice that the credible interval for honors is very positive. So that's showing that honors students are much more likely to get a problem correct on their first or second try, which is what we expected. And the credible interval for doing practice problems on day 1 is negative, showing that these students are less likely to get the problem correct in their first 2 tries. Additionally, students who did practice problems first were more likely to give up on the homework. So these are the effects of different factors on the number of incorrect attempts that students made on homework before either getting the problem right or giving up. And you can see that the effect of doing practice problems on day 1 is negative. So these students tended to have fewer incorrect attempts, even though, as we saw in the previous slide, they were also more likely to get the problem wrong in their first couple of attempts. So it seems that these students are tending to give up before they get the correct answer more often than students who did video examples on day one. So overall, we found that video examples on day one, during students' first contact with material, are associated with better long-term performance. And this agrees with previous results about reading written worked examples. Some possible explanations for this include that video examples reduce the cognitive load compared to solving practice problems, which is consistent with what we saw in the difficulty ratings. It's also possible that the video examples better prepared students for FAR transfer. The problems on the mid-test and post-test were quite similar to the practice problems that students had seen, either that they had solved themselves or watched in videos. Whereas the problems that they saw in homework were of a greater variety of types. So doing better on the homework could indicate that those students were better prepared to do that FAR transfer. We additionally saw that students who did video examples on day one exhibited better persistence on the homework. And this could be because watching the videos forced students to slow down and focus on the process of getting to the correct answer, rather than being primed to focus on just the correct answer, which is what was provided in the key for the practice problems. I'd like to thank my student, Andrew Senapadaratne, and the UW-EC Office of Research and Sponsored Programs for supporting this research. You can find the playlist of video examples in the link in the discussion forum, as well as an app where you can explore the data yourself in the discussion forum. Thank you all for your attention.
Great, thank you. We're going to open it up to question now, so please put your questions in the Q&A and I will watch for those. Abra, one question to get started. Do you think, you said that those who did the practice problems first actually did a lot better with the short-term practice. Did you see any frustrations or felt frustration as the instructor from students who didn't see the immediate results of being better at short-term problems related to the videos?
I can't say that I noticed that
Okay.
because we collected the mid-test and post-test and then handed them back later. So I think there was enough of a disconnect that students weren't exhibiting a marked frustration in that. But that's a good question.
Thank you for that. Yeah, the curiosity comes from sometimes when students don't have easy success at the beginning, that also affects their willingness to keep trying. So that's why I thought it'd be an interesting follow-up to a study, maybe.
Yeah.
I also had a question from an instructor perspective of how long did it take you to prep then these video examples instead of using, or did you use the textbook along with it?
So many of these questions came from the textbook or other ideas that Andrew and I generated. The videos are all very short, about 3 minutes long. And you'll notice if you watch them that they're nothing fancy. They're narrated PowerPoints. So it didn't take a huge amount of time to prepare them, if similar to preparing a similar quantity of length of videos for an online course.
Great, thank you. Next question. Was there a similarity in the problems shown in the video and the problems that they worked? Were the levels similar?
Yes, so all students on day one were seeing the same problems, either in the videos or in the practice problems. And then all students on day two were seeing the same problems as their classmates, but different problems than they had seen on day one.
So when you did the prep video, it would have been similar enough, the concepts, but they still had to know how to apply the information to the homework problems?
So comparing the in-class videos to the homework, yeah, I would consider those to be all similar levels of difficulty as is appropriate for introductory statistics. But the homework problems included problems where students needed to identify the correct type of test in order to solve the rest of the problem, such as to find the p-value, even if they weren't being explicitly asked, what type of hypothesis test should we consider? Are the validity conditions satisfied?
So they would have known that key information, or they would not have been able to work through the homework problems.
Right. So that's why I say that the homework problems often involved more FAR transfer than the mid-test and post-test.
Thank you. I'll just give one more look if there's any other questions. And just a reminder, Abra said that you're more than welcome to use any of the videos that she provided as well if you're there, if you teach statistics. So thank you so much for that. And thank you, Abra, so much for your time today and your research.
Thank you.
All right, we're going to just get set up with our next presenter. So just hang on for a few seconds here. All right, and our next presentation is use of graphical analysis for virtual general chemistry laboratories. Sheri?
Hi, I'm Sheri Lense, and I teach chemistry at the University of Oshkosh. And as said, this talk will be on the use of graphical chemistry laboratories. Next, please. Oh, next, please. Just a little bit of the laboratory in chemistry. It's always found a little bit interesting. Up until the mid to late 19th century, chemistry classes actually didn't involve much of.
Sheri, we're just having a little trouble with your mic for a second. I'm gonna see if
okay.
Maybe it's a little. Please try speaking now.
Okay, how is it now?
Sheri? Better, thank you.
Now? Okay, excellent. So just a little history on the role of laboratory in general chemistry. Up until the mid to late 90s, actually didn't involve much laboratory work at all. They were mainly lecture and recitation, and the use of laboratory was popularized in the mid-19th century by Justus von Liebig in Germany, and then by the late 19th century, it became an integral part of science. Fast forward to spring 2020 to the present, and now, as we all know, many laboratory courses had to either move completely to the COVID-19 pandemic. Next, please. Oh, next.
I think we're still having a little bit trouble.
Okay.
Will, any suggestions?
I
hear you well right now. I don't know if it's when you're moving or what's happening, but we'll keep trying.
Okay. Well, I guess next in that case, can you hear me now?
Yes.
Okay. So on to the next slide then. So at UW-Oshkosh during the spring 2020-2021 year, I taught 2 general chemistry classes that required the stories. In the fall, I co-taught a general chemistry 1 class we call Oshkosh. And that class had about 200 students total. The majority of the students attended lab in person every other week, and then on their off weeks, they complete a virtual lab asynchronously. And this was in order to allow for social distancing in the laboratory. A smaller portion of the class opted to take the class completely virtually, so they completed virtual labs each week asynchronously. Students taking the class in person had to quarantine at various points during the semester, and most often they would complete virtual labs during this. This semester, spring 2021, I'm teaching a virtual section of our General Chemistry 2 class, which we call Chem 106, that has 131 total students. And then this semester, a portion of the class has opted to take the class completely virtually. This section was scheduled as asynchronous, and these students complete virtual labs each week. Next, please. Next. Thank you. So in deciding how to design the virtual component, we considered two main ways to design the virtual labs. One was to use a commercial virtual lab package, and the other way was to use free virtual labs. And each method had pros and cons. As far as the commercial virtual labs are concerned, many of those provide interactive laboratory simulations, and students can make observations, collect and analyze data. And some also have additional features such as video experiments and techniques. These tend to have a higher production value, and then, of course, they may require less instructor time at the outset. A con with these, though, is that many require purchase of a semester-long subscription, and that didn't work as well in a class like the one where we were teaching, where students were having to move online intermittently rather than for the whole semester, or when only a portion of the class was doing labs online. An alternative was to use free virtual labs, and these use free graphing and free virtual labs free graphing and free virtual lab software to allow students to collect and analyze data. Big pro here is that they were free, and then they were very flexible. They could be easily swapped for in-person labs when the labs were moved online intermittently due to, say, quarantine, or when only a portion of the class was doing labs online. Cons were the instructor time that these labs took to design and write, and that they did lack the production value of some of the commercial lab packages. Next, please. We decided on free instructor design and written virtual labs in order to maximize flexibility. Virtual alternatives to in-person labs were provided each week, and the labs were administered through our course learning management system, which was Canvas. The students completed and submitted electronic lab notebooks through Canvas, and this is how they were assessed each week. Because of the way the classes were scheduled, the students completed the labs asynchronously. They were encouraged to ask questions either during office hours or via email. Next, please. So the goals in designing the virtual labs were to provide real data and problems to allow students to explore concepts covered in the lecture portion of the class. And that was to keep it consistent with the students doing the in-person lab. It was important that it be connected to the material covered in the lecture component. We also wanted to help students develop graphing, analytical, and computational skills, and then introduce students to laboratory techniques commonly encountered in general chemistry. An example would be titrations. Next, please. So one of the tools that we found valuable in designing these virtual labs was a program called Graphical Analysis. That's a free online graphing program produced by Vernier, and it's available for a variety of operating systems. If you use Logger Pro in your labs, Graphical Analysis is just the free version of Logger Pro. Graphical Analysis allows students to graph, fit, and perform calculations on data, and then interpolate and extrapolate using the graph data. And we use this program in virtual labs that required graphing and graphical analysis, not in all labs. And then we also used it in conjunction with either previously collected student data or virtual simulations to replace in-person labs. Next, please. So here are a couple of sample virtual labs. Next, please. One of the labs we used in the graphical analysis program was a virtual alternative to our kinetics lab. General Chemistry 2 students taking the lab in person at UW-Oshkosh do a kinetics lab each year where they determine the rate law and the rate constant at room temperature of a reaction between FD&C, blue dye number 1, and then bleach using something called the integrated rate laws, which are a mainstay in kinetics. So basically, they mix together dye and bleach solutions. As you might expect, the color of the dye fades when it reacts with the bleach, and they monitor the kinetics of this reaction. In person, the students perform an experiment in which they combine the dye and bleach and then monitor the concentration of the dye over time. And one of the learning objectives of the in-person lab is for students to learn to use graphing software to create dyes of the dye concentration versus time, and then perform computations on this data to create graphs of the natural log of dye versus time and 1/, dye concentration versus time. Students also learn to perform linear fits on the graph and then use these integrated rate laws to determine the order of the reaction with respect to dye concentration. Next, please. So important learning objectives in the experiment that we figured could be adapted to a virtual asynchronous learning environment were the ability to create graphs using graphing software, the ability to utilize graphing software to perform calculations on data, the ability to interpret graph data by comparing linear fits and slopes, and the ability to utilize the integrated rate laws to determine the rate law of a reaction. Next, please. We structured the virtual labs to contain an introduction with theoretical background, then a description of how that data was collected in the lab. The students were then provided with a data file containing actual student data in a format that could be opened by the graphical analysis program, and then detailed instructions on how to download and utilize the graphical analysis program, and then create graphs, perform calculations on data, and perform linear fits. Next, please. And just an example of the level of data, we kind of learned the hard way during the fall 2020 semester that we really needed to provide a significant level of detail just to minimize student frustration and allow them to concentrate on the lab. So for example, I put just a sample of the instructions given as far as downloading the data file and opening up, and we basically provide for every contingency that could happen, just so that students aren't left with their wheels spinning if they begin the lab half an hour before, or not half an hour, but a couple hours before it's due and can't get a hold of an instructor. Next, please. And then again, just showing kind of the level of detail. So it just takes screenshots of every step they needed as far as operating the software, not as far as actually analyzing the data, but this helped alleviate a lot of frustration when the students were doing the labs independently and asynchronously. Next, please. So the students were able to utilize the graphical analysis program to perform calculations and then create the dyes of the dye concentration versus time, natural log of dye concentration versus time, and 1/, dye concentration versus time. They're also able to use the program to perform linear fits and then use their graphs and their knowledge of the integrated rate laws to determine the order of the reaction with respect to dye. And overall, most students were able to generate the graphs correctly and then arrive at the correct rate law for this reaction. Next, please. And then the other main way we've used this program is to utilize it in tandem with free virtual labs, such as those available through Chem Collective. So for example, we used a virtual titration lab available through Chem Collective. Next, please. And this is just showing the Chem Collective website. Looks like I'm running out of time after the sound problem, so I'll go through this a little bit quickly. But we had the students perform a virtual titration, and when they're doing that titration, they're just adding a solution to another and then looking at the pH and recording the pH as a function of the volume of the solution they've added. So they're able to use the graphical analysis program, entering their data into there, and then creating a titration curve in conjunction with the virtual lab simulation. Next, please. And then again, students were able to manipulate the data, in this case, determining a first derivative of the curve and using that to find an equivalence point for their titration and identify the concentration and the strength of the acid. Next, please. So Couple of points in summary. The verneural graphical analysis, it proved to be a valuable program in virtual labs that allowed students to graph, fit, and perform calculations on data, and also interpolate and extrapolate their graph data. The program can be used in combination with either previously collected student data or free online simulations to give students a chance to collect, analyze, and interpret data. And the lab allows for flexibility in accommodating students who need to move from in-person to online on a temporary basis, or if you have only if we had only a portion of the students taking the class online. Okay, and with that, we'll wrap up my presentation.
All right, thank you. Again, if you have questions, please post them in the live Q&A section. One question I had for you, what was the hardest part of using these virtual tools when doing your online lab?
Right. If I could have chosen, I would have done it synchronously. I think one of the hardest points was that there was so little contact with students compared to usual. I was hoping more would say come to office hours and ask for help then, but usually only a handful of students were doing that each week. So I think the connection with students was really lacking compared to how it is in typical semesters.
Another question was, what do you think you will take from this online experience that you created and will use in future semesters when it may not need to be online anymore?
Right, that's a good question. We've kind of talked about this because one thing that came up was that if students were ill, say for a week, should we have an online alternative? I thought, well, usually if students are sick in a typical semester, they're too sick to really be doing even an online lab. We want to give them a break. But we might use it, see if students are like a sports game or something like that, and they're away from that. And then I do think one thing that was helpful was just developing some more detailed instructions. One of the challenges with a 24-person lab sometimes is getting around to all the different groups. So that they can actually concentrate on the lab rather than technical difficulties. So I think, now that kind of having an idea of what level of detail they, can help them work a little bit more independently, that would be helpful to incorporate in the future.
Our next question, is there anything that was done better with the virtual lab compared with your in-person labs?
I would say I'm still a big fan of in-person labs. So I'm not sure if I would. I don't think, unfortunately, I can say that.
That's okay. That's fair. And one final question. Do you anticipate in the future that your college is going to be interested in having the online option, or do you anticipate that it'll go back to the physical, but maybe having that graphic analysis pulled in for the graph parts of it?
Right. That's a good question. So for these classes, the 2-year colleges that are part of UW-Oshkosh, I believe, let's see, I'm trying to remember which one. I think it's Fox Valley or it might be Fond du Lac. They have an online option already. So ideally, students who are interested in the virtual option will be able to take a completely online class through, I do believe it's Fox Valley that has that.
Thank you. And I'm not seeing any other questions, so I would like to thank both of our presenters today, Abra and Sheri, for being here today. Thank you.
Thank you.